Because.
We are recording.
Jesus.
Okay, today is November 3rd, section 5.1, parallelograms. First thing you're going to get today is the definition of parallelograms, which is going to be a reason in proofs. Sometimes it's necessary. Okay, so this is the definition of a parallelogram. I'm not writing it on the board. You're going to write it on your paper, though.
Hold on.
A quadrilateral with both pairs of opposite sides. A quadrilateral with both pairs of opposite sides parallel to each other. Yes, Will. Sure.
Parallel with what?
With each other. And if you look at the picture drawn on the board, please draw it in your notes. The opposite sides are marked parallel. A quadrilateral, remember, is a four-sided figure. It has two pairs of opposite sides. Those opposite sides are parallel to each other. That is the definition of parallelogram. We're going to learn three theorems which can be proven that gives us other pieces of information about parallelograms. Then eventually we're going to get into special types of parallelograms, like squares and rhombuses. All right? But for now, let's get into the three theorems. The first one says this, that opposite sides of a parallelogram are also congruent. Not only are they parallel, they're also congruent. So if we're given the information that we have a parallelogram, we automatically know that the opposite sides are parallel and congruent. The next thing says the opposite angles of a parallelogram are congruent. So if you're told that a four-sided figure is a parallelogram, you now know that opposite sides are parallel, opposite sides are congruent, and opposite angles are congruent.
I didn't get that last thing.
Opposite angles are
No,
congruent.
not that. No, it was. Wasn't there something?
No.
We were supposed to write
It was just a parallelogram picture.
it. Like, no, on this page.
No, it was, my battery was dying.
Oh.
The diagonals of a parallelogram bisect each other. Does anyone remember what a diagonal is from when we
It
were
goes from
Cutting across.
from vertex to non-consecutive vertex? Okay. Now, in a parallelogram, you only have two diagonals. And there is a theorem that says those two lines bisect each other. So what does that mean?
They divided into two equal halves.
Two equal angles.
Two equal segments. If segments are being bisected, then they are equal to each other. Okay, this is a proof to show how we can conclude that if it's a parallelogram, then the opposite sides are equal to each other. Okay? We're not going to list out all the statements and the reasons, but we're going to prove through the use of congruent triangles, God bless you, and corresponding parts on those congruent triangles that that is true. Now, if you notice, there's a dotted line drawn across the parallelogram, which would be one of the diagonals. We have angles 1, 2, 3, and 4 labeled, so we're obviously going to be using them in some form or fashion in order to prove that the two triangles that I've just formed are congruent to each other. All right, well, we're given first that we have a parallelogram. What do we know way back from like chapter 2 or 3 that parallel lines cut by a transversal form?
The corresponding angles. Two congruent triangles.
Okay, they form alternate interior angles that are congruent to each other. They form same side interior angles that are supplements to each other. They form corresponding angles that are congruent to each other. Well, in this case, if the top two lines are parallel, and this dotted line is the transversal, then angle 2 is congruent to what?
Angle 1.
Angle 1.
Because they are,
Alternate interior angles.
and if these two sides are parallel to each other, cut by this transversal. No, I'm sorry, same transverse. I did it backwards, sorry. Angle 3 is congruent to angle 4 because they are alternate interior angles. Yes, Sam? Oh, sorry.
That's a problem.
Okay. Now, if we're going to try to prove that those two triangles are congruent to each other, we've got 5 different ways of doing them. We can automatically rule out hypotenuse leg because there's no 90-degree angles. We can automatically rule out side, side, side because I'm trying to prove that sides are congruent. Yes, Jacob?
Angle, side angle.
Because
Reflexive property.
through the reflexive property, EG is congruent to itself. All right, so if the two triangles are congruent, then the corresponding parts of them are also congruent, right? Well, just look at the triangles. Which side would be corresponding to EH?
FP.
FG. Which side would be corresponding to EF? HG. And so through theorems and definitions and postulates that we have already proven, we have now proven another one. That automatically, if you know you have a parallelogram, then you know that opposite sides are congruent to each other. Now, using this same information, we also know, because look, we've already proved congruency, right? That opposite angles are congruent to each other. Using a different color.
That was angle, side angle.
That was angle, side angle. Okay, we've already proved this information. We've proved that the triangles are congruent. Now let's talk about the whole parallelogram. If these two triangles are congruent, what do we know about angle H and angle F?
They're congruent.
They're congruent to each other. And those are the opposite angles in the parallelogram, right?
Right.
And we know that the sum of these two angles is congruent to the sum of these two angles because they equal each other. So opposite angles in a parallelogram are also congruent. And we would have proven that through the same type thing. Prove the triangles congruent, prove the corresponding parts congruent. And you'd have had a little bit of an angle addition postulate going on right there. All right, bisecting each other. How can we show that the diagonals bisect each other?
Do we have to be drawing?
It would be a good idea.
We have proofs in the homework.
Yes,
Why?
because you need to learn how to do it. All right, we are given that we have a parallelogram. So according to what we've already learned, we know that opposite sides are congruent to each other, don't we? Let's just start with this. Okay? We know opposite angles are congruent, but we don't really need that right now because I don't have a complete opposite angle labeled here. I'm going to try to prove that QS and TR bisect each other. So basically, I'm going to try to prove that M is the midpoint of those two segments. Now, how can I do that?
You just said the theorem that you told us.
No, I'm trying to prove the theorem. I can't use a theorem to prove it. It's like saying, what's perpendicular? Perpendicular. Okay, well, you have to get specific. All right, what do we see here?
Vertical incline.